Hello, this is a screencast for combining like terms with rational coefficients. After watching the screencast, you should be able to combine like terms with rational coefficients. And just as a reminder, the word rational pretty much means decimals and fractions. Before beginning this lesson, you should have a really good understanding of how to combine like terms in general with pretty or integer coefficients. Then we're going to learn how to do that with rational coefficients. And the reason that we need these lessons is for when we get to equivalent expressions and solving equations. We want to be able to combine like terms with whatever kind of coefficients there are. So, because we're going to be working with decimals and fractions, let's talk about the best tool that we have in math for pretty much Algebra 1 or Math 1, our freshman level subjects. This is just the best tool that we have. It works with decimals and fractions beautifully. It also has some other tools that we're going to find quite valuable as we progress through our math class. So this is the calculator that we recommend. This is also the calculator that I'm going to be using for demonstration. So let's take a look at our first example. What we're going to do first is look for our like terms. So I happen to see two like terms, 5/8 v and 2/3 v. So those are the terms that have the same variable. The terms that are just constants, the numbers that are not with a variable, that would be -11/8 and 2/7. So what we're going to do is work to combine the like terms. So sometimes something that is helpful is to rewrite the problem so that our like terms are closer together. Just keep in mind that this is an optional step, something that you might want to do as we're beginning problems, or if a problem seems complicated. Never be afraid to add this step in. So now my next job is to combine the 5/8 v and the 2/3 v. And I really do not want to work and get a common denominator. So what I'm going to do is use my calculator to add just the coefficients 5/8 plus 2/3. So on this calculator, you have a couple choices. The one that I think comes more naturally is typing the 5. And then this n over d key, that is going to take you to a fraction. And this particular calculator, it's in something called math type, and you will see the fraction right in there. So my denominator is 8. Now, something a little tricky is you need to make sure that you arrow out of the fraction before you add an operation. So my next thing that I'm going to do is add 2/3. Now your other option that you have is typing the fraction key first and then typing your numerator, arrow down to the denominator, type your 3, and then as a good habit, always exit out of the fraction. So now that I have 5/8 plus 2/3, I hit enter, and I get 31/24. So when I write that answer down, I want 31/24 v. Okay, now I'm going to combine these last two terms. So right down here, that is your negative. So I want to make sure that I'm typing -11. Whoops, sorry. I can delete that extra negative. I'm going to hit that n over d, which stands for numerator over denominator, 8, arrow out of the fraction, and then plus 2/7. Enter, and we have -61/56. So I write that part of my answer down, and we're done with the problem. So the beauty of having this calculator is I can just type in my problem and it's pretty much going to give it to me. Just something to keep in mind, whenever a problem is given to you as a fraction, unless the directions state otherwise, your answer should be as a fraction. Now, the last thing that we want to talk about is improper fractions. As we're going to be moving through our curriculum, the mixed number needs to go away. We only want to use a mixed number if the problem is like a word problem or a story problem, or if the original problem had mixed numbers. Whenever given the opportunity, you need to make sure that you are working with an improper fraction. Okay, so now let's take a look at our next example. This time we're dealing with decimals, and this one is a little bit different because we have parentheses. So the first thing I'm going to look for is, can I simplify what's inside the parentheses? And that is no. Now I need to remember that the invisible operation between this number and the parentheses is a multiplication. So I need to keep in mind that that's a multiplication problem. And at the very tacked on to the end is a subtraction problem. Well, order of operations says I do multiplication before subtraction, so I am going to do this multiplication, and that means I'm going to distribute. So I'm going to distribute that negative 8.37. So the first thing I'm going to do is multiply that by the 2n. So here's writing it out, negative 8.37 times the 2n. The symbol inside the parentheses is a negative, is a minus, so I'm going to write down that minus. And then I'm going to distribute the negative 8/37 by the 9/7. And there we go. And then just because we need to get used to showing appropriate work, I can't ignore that negative 9.1n. That just kind of has to come along for the ride. So this is what appropriate algebra looks like. Now, for some of you, you might be asking, do I have to show this step? And no. This is an optional step of showing what you're going, that additional multiplication problem. If you want, you can go straight to multiplying the 8.37 times the 2n. So let's go ahead and do that. Negative 8.37 times 2, negative 16.74. And then because we're multiplying by n, we keep the n. I keep my minus symbol. And then we're going to multiply the next set. And that is our answer, negative 81.189. And again, we need to continue writing every part of our problem down. That negative 9.1n does not disappear, and I'm not going to add it on at the end of my problem. I need to make sure that each line follows through. Okay, so we do have this minus and negative. We do know that when we subtract a negative, that's the same thing as adding. If you want, you can rewrite your like terms closer together. That's completely up to you. So again, this is an optional step. But if you can see that we're going to be taking that negative 16.74 and adding that to the negative 9.1, we're looking at negative 25.84n. Whoops, sorry. And then this had no other like term, so it's just going to come right now to that positive 81.189. So there you go, combining like terms with rational coefficients. So hopefully you've seen two good examples that can help you combine like terms with rational coefficients on your own.